Hello everybody, welcome to TranseLearning Chemistry videos. Today we'll be discussing about heat capacity and specific heat capacity and practice problems related to it. So let's see what all questions we'll be covering in this video. The first question, how much heat energy is gained when 0.6 kg of water at 25 degrees Celsius is brought to its boiling point? Specific heat capacity of water is given 4200 joule per kg per Kelvin. Here you can see the container carrying 0.6 gram of water, and initially the temperature of the water was 25 degrees Celsius. We need to calculate that how much heat energy is required to raise the temperature of water from 25 degrees Celsius to its boiling point. We know that the boiling point of the water is 100 degrees Celsius, so the final temperature will be 100 degrees Celsius. The first step is to write what is given and what needs to be found. Here, mass is equal to 0.6 kg. We will check the units. The unit of the mass is kg, and the unit of specific heat capacity also has the unit kg. So there is no need for the conversion. As given in the question, the initial temperature is 25 degrees Celsius and the final is 100 degrees Celsius. So the change in temperature, which is delta T, will be a final temperature minus initial temperature, that is 100 minus 25, that will be equal to 75 degrees Celsius. And as I've told you earlier, then whenever we are taking the difference of temperature, that is delta T, then the change in temperature per degree Celsius will be equals to change in temperature per Kelvin. So we can write delta T as 70 Kelvin, and we will prefer this Kelvin unit because the specific heat capacity of water has the unit Kelvin, and we need to find the heat energy gain. So for this we will be using the formula. Heat energy gained is equals to mass of the substance, which is water, into specific heat capacity into change in temperature. As all the three values are given, so I will just substitute the values in this formula. Here Q equals to 0.6 kg into specific heat is 4200 joules per kg per Kelvin, and change in temperature is 70 Kelvin. So the unit of temperature, Kelvin, will nullify each other, and the unit of mass, that is kg, will nullify each other. So we are left with the unit joule, which is the unit for heat energy. So Q equals to 0.6 into 4200 joules into 70. So on solving this, we will get the value as 176,400 joules. This is the amount of energy required to raise the temperature of water from 25 degrees Celsius to 100 degrees Celsius. Next question. A liquid of mass 0.2 kg and temperature 135 degrees Celsius is cooled to 25 degrees Celsius. If the specific heat capacity of the liquid is 750 joule per Celsius degree, find the heat energy given out. So first of all, we need to analyze what is given and what needs to be found. The mass of the liquid is given as 0.2 kg. And we need not to do any conversion because the specific heat capacity also has the unit kg. So the specific heat capacity is given 750 joule per kg per degree Celsius. And as this liquid was cooled from 135 degrees Celsius to 25 degrees Celsius, so the initial temperature is 135 degrees Celsius and the final temperature is 25 degrees Celsius. So the change in the temperature, that is delta T, will be T1 minus T2, that is 135 minus 25 degrees Celsius, that is 110 degrees Celsius. We can also write it as 110 Kelvin because change in temperature degrees Celsius is equals to change in temperature Kelvin. Must be wondering that in the previous question I took T2 minus T1, that is final temperature minus initial temperature. Then in this question, why I have taken initial temperature minus final temperature? So let us take it this way. Here, when I took initial temperature minus final temperature, I got the value 110 degrees Celsius. Now, if I take final temperature minus initial temperature, I will get 25 minus 135, that is minus 110 degrees Celsius. So if you analyze these two, the magnitude is same, that is 110 degrees Celsius. Only the difference is in the sign. The minus sign in this case depicts that the energy is given out. So when we are taking the difference in the temperature into consideration, we will only consider the magnitude. We will not consider the sign, because plus signs depicts that the energy was absorbed, and the minus sign depicts that the energy is given out or released. And here we will just take the magnitude. So if you do the calculation this way, that is T2 minus T1, this is also correct. But usually and most commonly, we will always take the difference by subtracting the lower value from the higher value, irrespective of the fact whether it is the final temperature or the initial temperature. So if the final temperature is more, I will take T2 minus T1. If the initial temperature is more, I will take T1 minus T2. But as such, both the ways are correct. So now what we need to find? We need to find the heat energy given out. For this, we will be using the formula heat energy released is equals to mass into specific heat capacity into change in temperature. As each and every value is given, so we just need to substitute the values in this formula. Here, heat energy released is equals to mass into specific heat capacity into change in temperature. In this case, I will take degrees Celsius because the units of specific heat capacity also has degrees Celsius. So the units of the temperature, that is degrees Celsius, will get nullified, and the unit of mass, that is kg, will also get nullified. So the heat energy released will be 0.2 into 750 joule into 110. So on solving this, we will get the value as 16500 joules. So this is the required heat energy released. Thank you very much for watching this video. For more videos, you can visit our website TranseLearning.com. Have a great day.